So now we're at the last of our three types of word problems here involving rational equations. These are the variation problems, and these aren't too bad. They're not quite as easy as the work problems tend to be, but they're a whole lot easier, generally speaking, than the motion problems. So they're kind of in the middle there between the two. Anyway, they're really not too bad. What's the key idea with variation problems? The key idea is to know how to translate variation phrases or statements into equations, and that's what I'm going to show you how to do first. Once you have a handle on that, then working the problems is just a matter of following a pretty basic three-step recipe. The recipe itself is just more or less common sense. It's the only way you can really do the problem, but it just follows a certain order that you just do step 1, step 2, step 3, you're done with the problem. Not a big deal. It's all about that first step of translation, and once you get a handle on that, like I said, it's a pretty straightforward process. Alright, so let's talk about this translation business. First, we mentioned that there are two basic types of variation. Two types of variation that you're going to see in general. What are they? They are direct variation and inverse. Alright, so essentially all of your variation problems boil down to involving direct and or inverse variation. Sometimes you can have both of these in one problem, sometimes there's only one or the other, but they all boil down to one of these two guys here. Now what I need to do is to show you how to take phrases that involve words like direct variation or inverse variation and take those phrases and turn them into an equation. And once you see how to do that, that's the equation you're going to use to solve the word problem. So that first step of translation is the key step in the problem. Once you've got the equation, the rest is going to flow very quickly to get to the answer. Alright, so let me show you how to actually translate here. So we need to look at some phrases here. Let's start with phrases like this. So what I'll do here is I'll put the, let's say we'll call it a variation phrase here. A little higher than that, just make sure I have enough room on this board. Variation phrase. Alright, here's where the variation phrase will go, and then we'll have its translation over here. Alright. So let's start off with a variation phrase like this. Let's say y varies directly as x. Okay, now the letters being used, the x and the y here, these are generic variables. And that's why I might call that a generic variation phrase. I think I worded it that way in the notes. When you actually do a variation word problem, the letters you use will be matching the context of the problem. So in other words, if they talk about distance, you'll probably use a D for distance. You'll use a V for volume, use a T for temperature, or T for time, P for pressure, that sort of thing. So I'm just using X and Y right now because we don't have a little story to go along with. If we did, then we'd use the letters that are appropriate to the context of the problem. So no matter. It doesn't really matter what letters we actually use in terms of how you translate. So what does it mean for two variables to vary directly one with the other? What's it mean to have a direct variation between two variables? Essentially what it means is they behave in the same way, in the sense that as one gets larger, so does the other. Or if one gets smaller, so does the other. And so the way that would get translated looks like this. It's not like we're saying they're equal, not quite that much, but close to it. Here's the translation. Y equals kx. Now what is that k there? That k is a proportionality constant. Proportionality constant. And you've worked with proportionality constants before, to be sure. Have you ever converted metric to English or English to metric? For example, see what 1 pound is about 2.2 kilograms, something like that. Or 1 kilogram is 2.2 pounds, I can't remember anymore. I know that 1 mile is about 1.6 or 1.7 kilometers, something like that. But you got some kind of number in there where you use to convert, because you know that 1 mile doesn't equal 1 kilometer, 1 pound doesn't equal 1 kilogram. So there's some type of factor, a conversion factor, if you will, or proportionality constant that connects the two together. Now let me give you just some quick examples of variables that vary directly with one another. So just get a feel for things. Take a look at, suppose you're driving your car. Take a look at how far you can drive as it relates to how fast you're driving. So the faster you drive, the further you can get in a given amount of time. Now, if your speed slows down, suppose you get into some traffic, right? So your speed drops, then you're not going to be able to get as far. What's another example of direct variation? How about, well, suppose you work at a job and you get paid by the hour. So you got an hourly wage. And let's say for one particular pay period, you cover somebody else's shift, or you ask for extra hours, and they give them to you. And so you're going to be working more hours during that pay period. What do you expect the check to look like at the end? You expect it to be higher, right? Because the more hours you work, that varies directly to how much you're going to get paid. So the more hours you work, the more you get paid. Now, if your hours get cut for some reason, then you're going to expect less paid. That's a direct variation. And that's how it works. It's not too complicated to actually see it. But that's basically, you'd have an equation, and then the K is going to be what connects the two pieces that vary directly one with the other. In the case of working at a job, that K there is actually your hourly wage. All right, now, sometimes they're not going to use the phrasing varies directly as. They might word it this way. So here's an alternate reading to that. So they might say something like, Y is directly proportional to. Oops, spell that right. Directly proportional to. Means the same thing, though. Varies directly as, directly proportional to, means the same thing. So don't worry too much about whether they use the word varies or proportional. It's the word direct that you're really after, that you're paying attention to. All right, so that's one type of variation translation. Let's do one involving inverse. So let's do something like this. Y varies inversely as X. All right. Now, what does this mean? Well, this means that the two variables x and y in this case act in opposite fashion. In other words, as one gets larger, the other one's going to get smaller. Now, how do you capture that mathematically with an equation? Well, you're still going to have the proportionality constant there. It's just, it's the location of the x. The x is now down below that k. It's in the denominator. And if you think about this for a moment, you'll see how these two variables x and y vary inversely or act in opposite fashion. Think about what happens. As the x gets larger and larger, since it's in the denominator, the entire fraction, which is what y is equal to, the entire fraction gets smaller. As the denominator gets bigger, as x gets bigger, the entire fraction gets smaller, so y will get smaller. On the other hand, if you make x smaller and smaller, then that fraction is going to get bigger and bigger, and so y will get larger. So definitely x and y vary inversely, or they act in the opposite fashion. Now, if you want a quick example or two of how that might play out with an actual application, think about driving your car again. This time, however, think about how long it takes you to get someplace as it relates to how fast you're driving. So, the faster you drive, the less time it takes to get somewhere, doesn't it? That's why everybody speeds. Everybody drives like a maniac around here, because we're all in a hurry. We don't want to be late. And if we get caught in traffic and our speed drops, then we start sweating bullets because the time to get there starts to increase. I might be late. I might not make the appointment. I might miss the previews at the movie. Well, you don't even go to the movies. So whatever it is that you're trying to do and get there on time, if you get caught in traffic and your speed drops, so the speed goes down, the time to get there is going to go through the roof. Inverse relationship. Think about the gas mileage of your car. What about the gas mileage of your car? Well, as it relates to, say, the weight of the vehicle. Now, if you have a vehicle and you weigh it down, let's say you have a bunch of people, a bunch of luggage, let's say you're going to pull a trailer with a boat on it or something, so the weight is going through the roof. What's the gas mileage going to do? It's going to go through the floor, right? The more weight that you're trying to haul or carry in that car or tow with a trailer, the more weight you have, the lower your gas mileage is going to be. That's an inverse relationship. So that's how that would play out in an application. Now, just like we had an alternative reading for the direct variation, we'll have an alternative reading here for the inverse relation, and that'll be y is inversely proportional to. So y is inversely proportional to x. Just another way of saying the same thing. Proportional, too, if I can spell it right. There we go. All right. And this is the heart and soul of variation translation. Now I'm going to give you a couple more quick ones down here at the bottom because this will be useful as you go through the homework problems. You'll see this stuff pop up from time to time. Let's take an example of what's referred to as joint variation. So this would look something like this. Y varies jointly as X and Z. Okay, so what that means basically is X and Z are both affecting Y. How? In a direct way. That is, they're directly related to Y. At the same time, though. So how do you get it all rolled into one equation? It's not too hard to do. What it looks like is Y equals K, and you just go ahead and put the X and Z right in there next to each other. So both X and Z are on the numerator level, top level there. There's no denominators here. And they're both acting on Y at the same time. So whether I increase X or increase Z, Y is going to increase. So that's a joint variation. More than one variable is affecting the variable Y. Now, one last example here, let's do. Let's say we've got this guy here. Y varies, let's say it goes directly as X. So directly as X. And inversely as Z. Alright, so how is that going to get translated? Directly as X and inversely as Z. This is sort of a mix and match idea. In other words, take these two top translations here, one for direct and one for inverse, and imagine sort of rolling them together into one equation. All you got to do really is pay attention to where the direct variable goes versus the one that's inversely related. So you have Y equals, there's the K in there for the proportionality constant. You always got the K's in these guys. You always got to have that K in there. Now, Y varies directly as X, so X is going to be up in the numerator there because it varies directly. But what about the Z? Inversely as Z, when it's inversely related, that puts it down the denominator, so the Z goes down below. It really isn't that difficult to master that concept. If you vary directly, you go up in the numerator. If you vary inversely, you go down the denominator. And that's it. And then you throw the K in there because you always got to have a proportionality constant, and you got it. So if this last example here makes sense to you, that really pretty much contains all this stuff sort of rolled into one. It has everything you're going to need for these problems pretty much. Alright, so that is how you translate. Now, we're going to do some examples of how to use this stuff to solve our actual word problems in the homework and so forth. And there's a three-step recipe that will go with this. I'm going to show you that three-step recipe on the next problem, or sorry, the next video. That way this video doesn't get too long-winded. But this is the essence of how to translate. Now we'll take the idea, put it into a nice simple three-step recipe and show you how to use it to solve the word problems you're going to encounter in the homework.